Good morning, guys. Today we're going to go over 8.1 vectors, which is a very theoretical class. There's no math involved in today's class, just theory. Although there will be homework today, very easy homework. Pretty much when we look at certain physical quantities like temperature, 30 degrees Celsius, 45 degrees Fahrenheit, 0 degrees Kelvin. You can look at different other, miles per hour, 300 miles per hour. You can walk 50 feet to the east. The wind blows 30 knots. The wind blows 30 knots to the south. So some of these magnitudes, the quantity is called the magnitude. So for example, temperature 35 degrees, that's the magnitude. Speed 45 miles per hour, that's the magnitude. The difference with the vector is that magnitude has a clear and defined directional element to it. So for example, if I say I walked 500 feet, no direction, that would be a scalar magnitude. A scalar quantity, 500 feet. If I said I walked 500 feet due south, I'm adding a direction to that scalar quantity, it becomes a vector. So again, scalar quantities have no directional element. Vector quantities do have a directional element. So for example, the wind blows 30 knots. That's, like a sailing term. Yeah, no direction, scalar. The wind is blowing 30 knots, 45 degrees east of south. Well, now I have a directional element that becomes a vector. Now note, this can be a little confusing for a couple of reasons. Most of you haven't taken physics classes yet. And this is going to be an incredibly important class for physics and a lot of math related classes. Again, when you start going, the people who are going to go into math, vectors are used a lot, pretty much. A lot in physics and math classes. And believe me, college level physics classes are the most difficult classes I've taken. And I've been through the entire med school. Physics 2 and Physics 3. Vectors every day, they were very, very difficult. The most difficult classes I think I've taken. Now, we're not going to go into actually, you'll see that in this book, the way it's presented, it's incredibly simple, so you won't have a problem here. We're not going to go into heavy, crazy vector math. The one thing you have to note is that sometimes the directions of the vector are not explicitly stated, and sometimes there are scalar quantities that are given a direction just by the way that we use our English. For example, you guys say in the classroom, I'm used to this. Profe, el aire está muy duro. Tú puedes bajar la temperatura. Can you increase the temperature? Can you decrease the temperature? The temperature is going up. The temperature is going down. Again, up and down are directional elements. But when you think about what's really happening, the temperature itself is not going in the upward direction, or the temperature itself, it's not going downward, wherein it's getting colder. That's just the way we use English or Spanish. So even though I say the temperature is going up, or the temperature is, rising or increasing, that is not a directional element. That's just used to That's a different way of saying it's getting colder or hotter. There is no directional element to that up or down in this particular sense. That's why it's sometimes a little tricky. And you do have to actually think and say, okay, is this actually moving up or down, or is this moving somewhere? Then yes, again, if you begin at a point and you move somewhere, that's a vector. We're going to get into the drawing now. Now, the other more difficult cases, and again, I'm not going to try to trick you guys with these cases in the test, but you do have to actually investigate if there is a directional element to some of these quantities. For example, weight. How much do you weigh? I weigh 400 pounds. Well, not 400. I weigh a little more than a little more than when quarantine began. I weigh about 200 pounds now. I don't weigh 200 pounds up. I don't weigh 200 pounds down. I don't. So there is no explicit directional element to weight. But when you look at the definition of weight, you know that it is always a downward pull that one man, oh, I don't actually know the definition, I'm not a physicist, but it's just a downward pull of the mass of your body. So mass would be a scalar quantity, but weight would actually be a directional. It pulls you down. Every body, every when I say body, I mean every element that is in our world is being pulled downward, and that's the weight. That's the directional element. Again, you don't weigh 200 pounds downward. The word weight includes a direction which is down. So that's why you have to practice and know all the terms that are in the exercises I will give today. I will not include a term that has not been seen in at least one of these exercises. And please don't ask me, Profe, do newtons, which is in the homework, have a directional element? Well, why don't you look it up? Google, is Newton a scalar quantity or a vectoral quantity? Boom, done. You're going to have to do a little investigation. Not that much. Google, 5 seconds. Scalar versus vector. Done. But you do have to know for example, is speed the same as velocity? Investigate, because that's in the homework. Is weight the same as mass, temperature? What other units do we know? We know temperature units, we know mass units, we know weight units, we know, you're going to begin to get to know a couple of work units, newtons, horsepower. I can't remember all the things I saw in physics, but there's a whole bunch of units, but we're only going to focus on the ones that are either in the examples or in the book. I'm going to talk about that at the end. We will have tests next week. I'm going to talk about that. Not about this subject. Let's get to tests at the end. Right now, just know that you have to investigate if you're not sure if there's a directional element or not to the term that you're seeing. You have to investigate the terms in the homework and in the examples. Terms that are not in the homework or examples will not be asked. Terms that are in the homework or the examples might be asked. So I recommend you know them. So again, the difference between scalar quantities and vectoral quantities: scalar is only a magnitude, a number that represents how strong or how weak that force is, and vector has a magnitude and a directional element. 500 feet south. Okay, that's pretty much it for scalar versus vectoral. Now, when we're gonna draw a vector, and you will be drawing vectors later on, not today, but tomorrow we're gonna be drawing vectors. The vectors, remember, we saw this in geometry. We have lines, we have segments, and we have vectors. I have what's called the tail, or the tail, or where with the origin, not the origin, the tail end where it begins, and the head or tip, which is like an arrow. That's where I'm moving to. That's the direction I'm moving to. So the tail and the head of the vector. Now, if the vector begins at the origin of a coordinate axis, that means it's, in standard form or standard position. I begin here. But know that vectors could also begin here or wherever. So when a vector's tail is on the origin, that's what's called standard position. Now you're going to ask yourself, Profe, but let's say this line is 7 feet, and this line is 8 feet, and this line is 10 feet. That's the magnitude. How do I know exactly I know it's pointing this way, so that's where it's going, but how do I know what direction I'm actually going towards? We use 3 different methods, and they are very simple. Now, 2 methods use the word bearing in them. And you can see this in many of the movies. Like if you see any of the ship movies, Yeah, please tell me your bearings. We're, 35 degrees due west of south. Bearing, the word bearing. Two ways use the word bearing, and one way just gives you a straight up angle. So if you don't see the word bearing, you know you're using the angle direction. And all you do is, from the original position, which is the positive side of the x-axis, you draw an angle with this magnitude. 145, 90, I can't remember, 145. Go 90 degrees. Again, I'm not giving the word bearing, 90 degrees. Go negative 30 degrees. Negative 30 degrees. When you do not see the word bearing in the description of the direction, you're going to use the angle starting from the original position, the default position, the polar axis, okay? The right-hand side of the X. Now, when you see bearing in the directions description, there are two ways you can see the direction when you're told bearing. If you're given, like, for example, north, west, south, east, that's one way to see it. In the other way, you might be given 3 digits. 3 digits. 3 digits. And I'll tell you why I wrote this one down. Now, when you're given an actual direction, the way this works is you're always going to include north or south. If I'm told north, I'm going to use this particular, line. If I'm told south, I'm going to use this line. And then they say, for example, I traveled 500 feet north. You just use 500 feet north. 500, done. They tell you 300 feet south. You go south 300 feet, done. Now, they can also include a east or west element to it. So, for example, if I say 30 degrees west of north, I'm going to use my north line, and from this north line, I'm going to draw another line 30 degrees in the west direction. So that is 30 degrees west of north. I go 30 degrees west of my north line. 45 degrees east of south. I'm going to use my south line, and I'm going to go east, which is this way, just in case. East 45 degrees. Again, when you're using this type of directional format, the angles will never be above, it's going to be between 0 and 90, okay? Because it's either going to be, these 90 degrees east of north, these 90 degrees west of north, these 90 degrees east of south, these 90 degrees west of south. And that's it. So you're going to draw the magnitude or the value and the proper direction when you're told east of north, west of north, east of south, west of south. There are no other ways to present this. They're not going to tell you 2 degrees north of west. Even though, okay, you can draw it, you go to the west line and then you go 2 degrees north. That's not the proper way to state these types of bearings. Again, you're going to use your north or south as your reference point, and then you're going to draw a certain amount of degrees either east or west of those lines. Now, many students confuse east and west. I mean, north and south are very easy. North and south, well, hopefully they're easy. North and south. Now, the way east and west goes, the way I was told to just memorize them when I was in school, was just think of how news travels. And if you go like this, it spells news. News. North, east, west, south. News travels fast. News travels. That's how I remembered it. Just make sure you try to remember it using another method, whatever, I don't care. If you mix up east and west, we have problems. So make sure you just write down east and west properly, okay? Now, the other type of way you can see the word bearing is when you're not given an actual direction. You're just given bearing and a degree value. Now note, you will always be given 3 digits, even if it's a 0 in front. You will always be given 3 digits. However, if you're told, for example, 135 degrees and you're not told bearing, that means we're going to be using the standard 135 degrees angle measurement. If you're told bearing, what that means is we're always going to be using the north line and we're going to go in a clockwise direction. So for example, if I'm told bearing 30 degrees, I'm going to begin at my north line. It's always going to be north. If you're told bearing and no direction, we're always going to begin north. If you're told bearing, 30 degrees west of south, you're going to begin at the south. When you're just told bearing and a degree, you always begin at the north line. And we go clockwise from there. So bearing 30 degrees or 30 degrees, you're going to begin at the north line and clockwise go 30 degrees. Done. Now, what's the difference between these two? The word bearing. Because why? I'm going to begin at the north line and now I'm going to go 125 degrees from my north line. Here, when you're told just an angle, remember, positive angles actually go counterclockwise. So let me give you that example. If I tell you, let's go over an easier one, bearing 90 degrees or just plain 90 degrees. If I tell you bearing 90 degrees, I'm going to begin here and in a clockwise fashion, I would travel 90 degrees. So my vector would end up in this direction. That means I'm going east. That's fine. If I just tell you straight up, I traveled 90 degrees, 500 feet in a 90-degree fashion, without including the word bearing, I'm going to begin here, my standard position, and then I'm going to go like a normal positive angle, 90 degrees. The difference between these two is including this word or not, which is key. And also, I forgot to put a 0 here. Remember, when we're told bearing 090, that's 3 digits. And again, that's it for directional elements. Now, the last theoretical class is talking about parallel, equivalent, and opposite vectors. You'll see that, we're going to have multiple vectors going in different directions later on, but just know that parallel vectors have the exact same slope, so to speak. So having the same slope means, as far as vectors go, they have either exactly the same direction, or the exact opposite direction. So they are going either at exactly the same direction or at exactly opposite directions. Note that even though I'm representing them as a line, they can also be like this. One element could be pushing in this direction over here, and the other element could be pushing to the left-hand side down here. You'll see how that works out later tomorrow. So parallel vectors either have the exact same direction or the exact opposite direction. The magnitudes could be different. You could go 500 feet here and 20 feet here. Doesn't matter. They don't have to be the exact same magnitude. All I care about when I'm dealing with parallel vectors is their direction. Same direction or opposite direction. Doesn't matter how big or small they are. So that's parallel vectors. Equivalent vectors have the same magnitude and the same direction. So pretty much they are identical. They can begin at different places, but they are identical. For example, I go 1 foot north, 20 feet east, and then 1 foot north. These two, 1 foot north, are equivalent vectors. Exact same direction and exact same magnitude. Bien. Doesn't matter where they begin or where, 1 foot north, 3 feet east, 1 foot south, 4 feet east, 1 foot north. These two are equivalent. They are both 1 foot north. Again, same direction, same magnitude. The last one is opposite vectors. Opposite vectors have opposite directions and same magnitudes. So they are pretty much like the equivalent vectors, only they are working against each other. Like say for example, I go 2 feet north and then 2 feet south. They cancel each other out. If I walk 2 feet north and then 2 feet south, I would end up exactly where I began. So again, let's go over all three. Parallel vectors have the same or opposite direction, same or opposite direction, but they can be of different magnitudes. So it's fine if they're different magnitudes. When I'm talking about equivalent vectors, same magnitude and same direction. So they are both the same, size, strength, units, and they are in exact same direction. Opposite vectors, exact same magnitudes, opposite directions. Up, down, east, west, north, south. Temperature going up, temperature going down. Speed increasing, speed decreasing. Okay, so again, they are opposite. That's it for today's class. Now, as far as homework goes, I'm going to have you do 1 through 8, or actually 1 through 6, in which all you have to do is state whether we're looking at a vector or scalar. You might have to investigate a little bit, but again, just write vector or scalar. Vector or scalar. Done. Should take you maybe 5-10 minutes. And the rest of them are 7 through 12, which is using different directional elements. Again, using the bearings, using the angles or degrees. And again, all I need are small sketches. You don't have to use a transportador to give me exactly 135 degrees. Just give me a ballpark of where more or less the direction you would end up facing. That's just important so you guys get used to the 3 different ways we can present the directions. Again, scalar versus vector, a small sketch, doesn't have to be perfect, just a small sketch of where more or less the direction you would end up at. That's the homework. Now note one thing. We had a meeting with the math department yesterday, and still there's no word on when school is gonna open. No word yet. So what I'm gonna do is starting next week, at the end of next week, I'm gonna start giving quizzes and tests. ¿Por qué? Because if I'm told that school is not reopening for the rest of the quarter, that means because we will be giving tests. You're not gonna go an entire quarter just doing homework. That's gonna save us from having to give multiple tests together. Now what we're gonna do is, I'm probably gonna give you the quiz next Friday. And just in case, it is not all the material we have seen so far. That would be crazy. I'm gonna give you exactly, just like normal quizzes, a very small block of subjects. What I'm gonna do is, if the quiz is Friday, I'm gonna give you guys Wednesday and Thursdays to review. Again, I'm gonna assign very particular exercises, which is how they're gonna show up in the test more or less. So Wednesday and Thursday would be full practice days. And on Thursday, I would upload a practice quiz so you guys know more or less how to expect, what to expect and how to work with the software. Because again, the quiz will be timed. And I don't want, profe, but I didn't know how to hit enter, or I didn't know how to write the answer, because that's up to you. And actually, I'm going to upload a practice test and maybe a small video on how to work the test, just so there are no excuses. It is your job to know how to use the software. If you have questions, and actually I might upload the practice test on Wednesday. In case you have questions, we have the entirety of Wednesday and the entirety of Thursday for questions, because I don't want to hear the excuse, prof, I didn't know what to do. And again, remember, we're going to have the test at a very specific time. It's going to be open, and a very specific time it's going to close. Make sure you're present, or you're going to have a 0. Because unfortunately, again, take-home tests, I don't want to give group tests. I want to give individual home tests. So it's going to be long, but we're going to have to practice. You really have to practice and make, just be sure on what you're working, because there will be very little room for mistakes. Okay. And that's pretty much it for tests. So, also, again, I believe that this quarter will be all homeworks, quizzes, and tests. And I will give also a research project later on, which is just, you don't have to build anything, just find information and maybe do an online presentation to just me with the information that you found. It's going to be a small project, maybe 1 or 2 students per group, no more than that. It's going to be very individualized to your particular situation and maybe the career you're interested in. So we're going to try to really focus on your career path and see how we can adjust a research project to your career path. So again, the groups are going to be 1 or 2. Do not say, Profe, can we have 3? The answer is no. 1 or 2 students. We will talk about the subjects that you're going to get and you'll be able to work. It's probably going to be due at the end of the quarter. And again, that's why the homeworks are also very important. The quizzes might be difficult. Also know that the quizzes are going to be less weighted than quizzes in normal class because it's not the same experience. Most of the weight is going to be homeworks. I've said it multiple times. Make sure you do not miss a single homework or you will end up failing due to missing 4 or 5 or 6 homeworks. Do not miss a single homework. At the end, I'm going to check every single day, which is saved in Teams. I'm going to check every single day, every single post. Review the homework. Sometimes I go ahead and review to see who's missing. Sometimes I don't. Make sure you do everything. Besides that, you have any questions on the homework, even though Fridays are practice and video conference days. If you have questions about vectors or scalar quantities or anything, you can let me know. We can set up a video conference any day. I am available. Just that Fridays are specifically for that. But again, any other day, you can let me know. We can set up a video call. If you have any questions, let me know. Otherwise, homework and investigate the terms in the homework that you don't know. Velocity. Is velocity scalar or vector? Is Newton scalar or vector? Make sure you investigate and know because that's definitely going to be on the test. Have a great day. See you guys tomorrow.